Good evening, VE enthusiasts. Today we are going to start rigid body dynamics, one of the most scariest topics for all the 11th and 12th standard and even the dropper students. So do not worry, I'm going to cover each and every bit of it in detail. And let me tell you, today at the end of the session, I'm going to make a special announcement. There is some breaking news coming for all the 12th and the dropper students. So wait for it till the end and I'm going to break that news for you. All right. And today we are going to start with moment of inertia and we're going to see what role it plays in our daily life. So a lot of you know what inertia is, but today we are going to discuss what is this rotational inertia or moment of inertia. Like for example, the flywheel of a car, it's an engine. There is a flywheel. What is the use or what is the purpose of that? What difference does it make if you have more radius or small radius? What difference does it make? So we're going to discuss that. Does a bigger tire or a smaller tire make a difference in the dynamics of a car? Does an 18-inch wheel, does a 16-inch wheel, does a 20-inch wheel change the dynamics of a car? Well, yes, there is something that changes the dynamics and that's what we're going to see. And if you leave or release on an inclined plane a solid cylinder, a hollow cylinder, a solid sphere and a hollow sphere, you will see all of them will not come at the same time. Each one will move differently irrespective of their radius, irrespective of their mass. The mass and radius does not have any role to play. We are going to discuss this problem in probably the third or the fourth session of rotational dynamics. But understand, moment of inertia has some role to play in this. And that's what we're going to do. And welcome aboard. This is Shreyas here, your master teacher for physics at Vedantu going live. Welcome to Enthuse channel, which is your JEE English channel, your preparation guide, all that you need for cracking the JEE Mains, JEE Advanced, BITSAT, CET, all the engineering entrance examinations. This is your one-stop destination for all your needs. And me, Wasim sir and Shimon sir are going to help you out to crack the examination. So a little bit of quick introduction about me. I'm Shreyas and I have been mentoring lots of students for the past 11 years. And understand, many of my students are actually in IITs, many of them are in BITS, many of them are in NITs, some of them are in ISERs, ISTs and ISC. So I hope that one day you too will be there. If you are in 12th standard, I'm pretty sure next year you're going to crack it, and if you're in 11th standard, I'm pretty sure the year after that you're going to carry forward this tradition. All right, so welcome aboard. And you can also follow me on my social media handle, which is Shreyas_Vedantu, and you can interact with me over there. I'm planning to go live very soon again, just like I did previously on Instagram. So I'll be going live very soon. So stay in touch, keep yourself updated, keep a track, and you will see me go live very soon. And I'm going to choose a very special topic next time. You will see what it is, but stay tuned. Welcome aboard Navmi, Princey, Achyut, Manoj, Jumna, Ankit, Prija, Sanspriya. Welcome aboard. Welcome aboard. I know a lot of your term exams are going on, and in spite of that you have come here. That's an amazing thing. Very good, guys. Welcome Shreya, Sneha, Dinesh, 17S Harni, VSG, Ashutosh, Aishwarya. Welcome Saurabh, welcome Ranjit, welcome aboard. Glad to see you all here. Nice and big, small and sweet. I can say a very good family that we have over here. So in case you have not yet joined our Telegram group, do join the Telegram group because we are going to post all the updates over there. Like the drill, the extracts, or maybe the session PDF or the homework solution or some special lecture coming up. So all the updates go on the Telegram group. Also, I hope you have checked all the formula lists, the property list, everything about momentum and collisions from the previous session. Check it out. If you have not checked it out, I've given all the formulas, all the important theorems, properties related to momentum and collisions in the extracts. So check it out. It is there in the description box, not of this lecture, but in the momentum and collisions lecture. Remember one thing, at the end of every chapter, I will provide you extracts just like I promised, which is a short summary but contains all the important pointers for your quick revision, and it will also help you make your own notes. Also, it will be posted on this Telegram group, so do not forget to join the Telegram group. And If you are new to this channel, do not forget to hit the subscribe button. That's the red button out there at the bottom. You will be able to see it. Hit the subscribe or else you'll miss out on the videos. And do not forget to like, because that's where I get all my energy from. So let's begin, guys. Let's begin. Thank you, Achyut. You like the quote. So it's winter, and in Bangalore also it's quite cold. Although I don't feel very cold inside the studio because of all the lights and all the UPS heat and all that stuff. So, but today it's cold, and I feel that I should also show you what kind of sweatshirt we wear at Vedantu. So you can check it out. It's a very cool sweatshirt that I just received from Vedantu today itself. So I thought I should just put it on, and maybe you can also have a look at it. And plus I'm feeling a little bit cold today. All right. Yes, it's a new sweatshirt. All right, so let's get going, guys. I hope you like the sweatshirt design, and you will see how it looks at the back when I start writing on the board. So stay tuned, and also a breaking news coming at the end of the session. Remember that. All right, so we have seen. All right, yes, Wasim sir also wore it today. I saw. Yes, it's awesome. Very good. Yes, Ranjit, I teach on Biotonic channel as well for special guest lectures only, but I'm a regular. I anchor the physics part over here at Enthuse. All right, so here we go. We have studied what inertia is previously, and I have shown you this cool animation out there. So inertia is a tendency of a body to maintain its state of rest or of uniform motion. So it maintains whatever was happening before. So the truck moves below it, the car has some inertia, it was not locked properly, so it slides back. So that was just inertia, but in translation. Now understand, there is also inertia in rotation, and that is called as rotational inertia or just moment of inertia. And the symbol for that is capital I. Understand that. So capital I is the symbol for moment of inertia or the rotational inertia. Now what does it actually mean? Let me tell you that, because a lot of you have doubts in that. So imagine you just get onto a merry-go-round and you push it. Sometimes it's very easy to push a merry-go-round, sometimes it's very hard to push a merry-go-round. If you find it difficult to push the merry-go-round, assuming you are applying the force at the same point, then the moment of inertia of that merry-go-round is very large. That means that merry-go-round offers big resistance to change its state of rotation. It was at rest. To get into rotation, it offers big resistance, so it has more moment of inertia. So something has more moment of inertia means it will offer more resistance to change its state or tendency to resist the change of motion. Understand? But rotational motion. Now what will it depend on? Obviously it will depend on the mass, it will depend on the size and how it is pivoted, on all those things. So we're going to see that very soon, but I hope you get that idea out here. Similarly, imagine you have a giant wheel and there is a motor over here which is trying to rotate this giant wheel. Now imagine this giant wheel is empty, nobody is sitting on it. Obviously it's very easy relatively for that motor to rotate that giant wheel. But the moment people start sitting in all these cabins of that giant wheel, it becomes much harder. It's a little bit tougher for that motor to rotate this giant wheel. What has happened? Understand, to change the state of rotation, it becomes harder. It has higher moment of inertia. Similarly, if this giant wheel was small, then it would be very easy for that motor relatively to rotate it. So moment of inertia definitely depends on the mass, the size, and sometimes also on the axis of the rotation. Right now, obviously nobody will rotate the giant wheel about some weird axis, but if one were to change the axis of rotation, maybe let's say the axis is like this and the giant wheel rotates this way instead of rotating like that, then it would completely be different. And very simple way to make you believe what I'm saying is, okay, just one sec, let me get it. Yeah, so imagine this scale. Imagine this scale. If I hold it like this, okay, and I rotate it this way, about this end. If I rotate it like this, obviously it's very difficult because a lot of the masses are really far and they are going, in big circles. But if I rotate the scale like this, then it's much easier because all the masses are now going in small circles. So the mass is same, all right, the size and the shape is same, but the experience I get is completely different when I rotate it like this or like this. See, I've changed the axis. If I rotate it here, it's different, and if I rotate it here, it's different. You can try it out if you have a scale nearby, and it's completely different experience when you rotate it like this. In fact, it's one of the easiest way to rotate the scale this way because all the masses are close by the axis of rotation. Are you guys understanding what moment of inertia is? Have you got the feeling of moment of inertia? Let me know in the chat box out there. All right, I hope you guys are understanding it. Yes, Achut, obviously this is rotational mechanics and this is the first lecture, and we are going to only disclose about moment of inertia today. Very good, Aishwarya, Saurabh, Manoj, Khushi. All right, yes, sure, Prakash. If you are in 10th standard, 9th standard and you want to start the early preparation also, yes, you are welcome. But sometimes it might be a little bit tough on you, so keep that in mind because there might be some things which you might be learning in maths or chem, and maybe because you are in 9th and 10th, it might go a little bit over the board, but that's okay. Just excuse for that part. All right, very good, Tanmay, Achut, Princey, Jumna. Now, let me tell you some very important pointers about moment of inertia. First of all, the symbol for that is I. The symbol for that is I. The unit of moment of inertia is kg meter square in SI units, and it depends on three things: mass, then the axis, and the last part, it also depends on the distribution of masses. Now think about it. If I'm rotating or spinning this wheel, if this wheel was heavy, it would be very difficult for me to rotate, so moment of inertia will be very large. If instead of rotating about this axis, I rotate it about this axis or some other axis, the moment of inertia, the experience that you will get, the resistance that the wheel is going to offer is going to be completely different. So it also depends on the axis of rotation. Also, why distribution? Maybe I keep the axis same, but just that I take the same masses and bring it close. If I bring those masses close by, then obviously the experience that you will get while rotating it will be completely different. Are you able to visualize this? Only then you'll understand why all the 3 pointers are important. I hope you are noting it down. In case you are new to the channel, let me tell you, all of us over here make notes while the session goes on, and you also have to keep pen, pencils, everything in handy because I'm going to give you some problems in a bit. All right, Hoin, don't worry, you're a little bit late. Actually, you missed some interesting parts. I was giving all the feeling of moment of inertia just some time back. All right. So I hope you have written it down, and there we go to the next part. So what is the formula for moment of inertia? And here it comes. The formula for moment of inertia is, assume that this is mass m1, this is mass m2, and this is mass mn. N is the nth mass, all right? And this is distance r1 from the axis, this is distance r2, and this is rnth distance, and this is my axis of rotation, all right? Direction does not matter, only it's rotating about that axis. Now, when you have n particles, the moment of inertia of such n particles is given by m1 r1 square. What is r1, r2, r3, rn, etc.? They are the distances of the particles from the axis of rotation. Keep that in mind. It's not the radius. That's a wrong way to look at it. It's the distance from the axis. Yes, it can be the radius of the individual circles where the particles are rotating, but it's not called as the radius. It's called as the distance from the axis. There is a small difference. Plus m2 r2 square, and like that you will have n number of turns. But some of them also prefer writing it slightly in a much condensed manner, and that could be like this. It will be mi ri square, where I goes from 1 to n. This is just a condensed manner of writing the same thing. It's summation. But this is to be used when you have discrete particles, when the particles are separate. There are, countable number of particles. But in a body like this, like a disk, a solid sphere, a hollow sphere, etc., the particles are not countable, and that's when you have to replace the summation with integration. Remember that. So the moment you have this, only difference that will be there is you will be having a dm mass, and that random dm mass will be at some random distance r. It's a variable, please understand, and this is again my axis of rotation. The moment of inertia of that dm mass will be, understand, it will be dm into r square. That's the moment of inertia of that small dm mass. So the total moment of inertia will be the integration or the summation. Remember, integration is nothing but adding infinitely many terms, but each term is very small. So therefore you will see the moment of inertia is integral dm r square. So these are the two formulas which you are supposed to remember, and from this is also very evident why the unit is kg meter square. Is that clear, guys? Very good, very good. Hi Satish, Manoj. Well, in circular motion the center is placed and the whole object doesn't move, but in car the wheel moves and also rotates, where inertia takes place. So Manoj, inertia, moment of inertia is discussed only for rotation, spinning. So when a car wheel moves, there are two events happening. One is translation and second is rotation. So for the rotational event I will talk about moment of inertia. For the translational event I will talk about just mass. I hope that's clear. Very good Science Priya, Aishwarya. Very good Manoj. Very good Nijarsan. Come on, I think you're late. Hi Karthik, come on, join in. What is MOF for rod? I'm going to give it. Achyut, hold on, hold your breath. I'm not running anywhere. I'm going to give it to you. Hold on. All right. So before we see all the moment of inertias, let me remind you about the pro subscription course. Guys, lot of you want to solve many problems under me. I know I have been getting plenty of requests and they're like, sir, we want to do more sessions with you, more problems. Yes, I'm doing it in this micro course, numerical course for JEE and NEET. Only problems, nothing else, only problems, and good level problems, easy level problems also are there. And derivations of all the chapters, all the theorems, all the properties also done. HC Verma booklet discussion done in this micro course. That's just the number of micro courses just I am taking in the pro subscription. Imagine the number of micro courses others are also taking, and imagine the options and the varieties that you have. Now these are just the micro courses for KVPY or be it Olympiads, etc. Apart from that, you also get the regular crash courses, the regular long-term batches, your regular test series, your regular assignment, just like you have in your regular offline institute. Now these are something which are additionals, but understand the online teaching that happens is completely recorded. You get the notes, whatever I write, you will get the notes, all right, not just the slides, also the notes. Now also you get assignments, and also you get personal teachers, class teachers, 24/7 doubt solving. That's what you get in this pro subscription. You don't have to pay individually. Oh, for tests you have to pay so much. No. You don't have to pay anything extra for any of this. It's just like your Netflix or Amazon Prime subscription, where you pay once and you can avail any benefit that is there inside that subscription. So let me tell you, for the droppers, for 6 months the course costs 51,000 rupees, but I'll give you a coupon code and you'll get 20% off, and that 51 goes directly to 40,800. And if you see per day cost, it's just 227 rupees, which is quite affordable. And for the 11th standard students, the price for 6 months is 24,000 rupees, and if you take 20% discount, and you will get it for 19,200, which is just 107 rupees per day. Again, very reasonable. So if you want the 20% off, what you need to do is go into the description box, hit that link. You will get all your questions, all your queries answered in the FAQs. Read it carefully, see how it is, and then hit apply coupon, and you have to use this coupon code to get 20% off, which is SHHPRO. That's the coupon code which will fetch you 20% flat off on any of the courses. You can also recommend it to any of your friends, relatives, cousins, you name it. All right, I hope I made it clear. Well, let's get going. Are you guys now ready to see all the formulas for moment of inertia? Let me know in the chat box, guys. All right. Hi techno gamers. All right, yes Manoj, let's see. Remember all these formulas. I'm going to give you some special formulas also. For a ring, okay, by the way, the axis is very important. All the axes, I'll just show it to you in light. All right, this is the axis. So the axis is the central axis, guys. Central axis. So if you rotate it about the center, the ring has a moment of inertia, mr square. Write it down 10 times at least. Come on, write it down. For a disk, it is half mr square. Come on, everybody write it down. Without that, it will not enter your head. Even if you think you know it, write it down. No harm. There is nothing wrong. Let 100 pages get wasted today. It's okay. Okay, half mr square. Hollow cylinder mr square. Solid cylinder half mr square. Now, do you see some interesting resemblance? Do you see some interesting resemblance? Okay. If blue pen is not visible, okay, here it is. I hope it is fine now. This is the axis. About some other axis, it will be different. Yes, do you see some? Yes, ring and hollow are same. Now that is the trick. What is the trick? Remember this trick, very easy. If you have a 2D object, all right, like a disk, you stretch it. When you stretch a 2D object like disk and stretch it, what will it become? Solid cylinder. Similarly, take a 2D object like ring, stretch it. What will it become? Hollow cylinder. Similarly, imagine you take a square wire frame. Square wire frame, stretch it. What will it become? A hollow cuboid. So understand all the formulas for moment of inertia. When an object from 2D is stretched to object in 3D, the formula remains the same. That's the trick. First trick, write it down. When you stretch 2D object into 3D object, the moment of inertia formula remains the same. Remember that. Yes, hollow cuboid means without the top face and the bottom face, only the vertical sides are there. So if you take a wire frame and you extend it, that's like a hollow cuboid without the top face and the bottom face. That's how it is. Yes, Ankit, hold on. Pehle formulas to dekh lo. Yes, thank you, Princey. All right. Next, formulas. This formula not many people give, but I'm going to give it to you. Very important. Sometimes JEE has asked questions on this. All right. For a rod about the central axis, it is ml square by 12. Remember, about the center, L is the length of the rod. ml square by 12. For hollow sphere, it is 2/3 mr square. Hollow means everything is inside is empty. It's just a shell. And solid sphere, it is 2/5 mr square. That's for solid sphere. Solid sphere is like imagine watermelon. There is that red part and that green part, so that's a solid sphere approx. But somebody eats the red part, only that green part of that watermelon remains. That's a hollow sphere. I hope you get that idea. And a right angle triangle is 1/6 mb square. Now what is this b? Well, if this is a right angle triangle, this side is A and this side is B. Understand, if this is my axis, very important, this is my axis, then it is mb square by 6. Remember that and write it down if this formula is not there in your books. Very good, very good. Yes, Moses, I'm feeling a little bit cold. All right, all right. Is that clear, everyone? Shall we go to problems now? Shall we go to problems? Is that clear, everyone? Okay, I hope you have written it down. Okay, thumbs up coming in, yo coming in. All right, let's get going. So here's your first question. Two masses m and 3m separated by r, rotating about the center of mass. Find the moment of inertia. All right, let's do this. Let's do this. Let's see how many of you do it faster than me. But anyways, I'll be a little bit slow because I'll be explaining it to everyone. But if you think you can do it, start it now and you can post the answers in the chat box. But I'll be doing it for the benefit of others, so I might be a little bit slow. So don't worry. Now, the question says, find the moment of inertia about the center of mass. Acha. So first thing we need to do is see where the center of mass is. This is m, this is 3m. Obviously, the center of mass is going to be somewhere over here, guys. And this is my axis. This is my axis. And this I can call it as R1 and this I can call it as R2. Now we all know, we have studied this in center of mass, that the distance of the center of mass is inversely related to the masses. The center of mass is always closer to the heavier mass, correct? And R1 by R2 is other way around. It is M2 by M1. So it will be 3M by M. Understand that. So it is basically in the ratio of 3:1. So R1 and R2 will be in the ratio of 3:1. So think about it. Also, R1 and R2 together is R. Total distance is R. So guys, what is the value of R1? Think about it. R1 will be 1:3. Divide it. Come on, guys. Come on, come on. It will be 3 by 4 R, and R2 will be R by 4. So that's how it is. R1 by R2 is 3 by 1. That's how the ratio is. And if you add them up, you will get back R. Is that clear till this point? This is a trick directly to find it out. In fact, in the exam, I won't be even writing this. I just wrote this part just for explanation. In the examination, I'll directly write these numbers because I know I have to divide the total distance in the ratio of 3:1. Remember it. Okay, very good. Now, once you get this, very good, Ankit, congratulations. Now, the moment of inertia will be M1 R1 square plus M2 R2 square. So what is M1? M1 is M. What is R1? That is 3 by 4. So it will be 9 by 4 R square plus M2. M2 is 3M. And what is R2? R2 is nothing but R by 4. So R square by 16. Oh, sorry, I have to put 16 also over here. My bad. 16 over here. Now it's fine. Okay. And that's about it. So I think you will get mr square by 16 as common, and inside you will have 9 plus 3. Now what is 9 plus 3? 12. And 12 by 16, guys, come on. So 12 by 16 mr square is what you're going to get. Divided by 4, you'll get 3. Divided by 4, you'll get 4. So hence the final answer is 3 by 4 mr square. Let's see how many of you got it. Let's see how many of you got it. Jumna has got it. Kya baat hai? And I think Jeevan also got it before. Wow, very good, Jeevan. And yes, Achyut, which month were you born in, yaar? Hold on, calm, chill, bro. I'm going to teach everything. Hold on. Don't be so eager. I know you are excited, but hold on, I have to teach everything, right? All right. Okay. Got it. Science Priya Manoj. All right. Very good. Techno gamers, you also got it? Acha, wait. I can't see it. But I think you have put it somewhere. Maybe. All right. Okay. Crystal clear. All right. Chalo, let's get going to the next question coming up on your screen. And here it is. So before going to the next question, let me just give you two simple tricks and then I'll show you that question. What is that trick? Addition and subtraction. All right, thank you, Dhanush. Addition trick. This trick I have also told you in center of mass. So the same trick can be applied over here as well. So understand, if you have a big body, something like this, and you want to find the moment of inertia, let's say about this axis. All right, you want to find the moment of inertia about this axis. What you need to do, break it into smaller parts, but keep the axis same. That's very important, and that's what a lot of people forget. So when you break it into two parts, make sure that the axis is here only. This is I1 and the other axis is over here. Let's say this is I2, and now I can say I is equal to I1 plus I2. So moment of inertia of two or more bodies can be added when you have the same axis. Understand? Look at that. This circle, the axis was here. If you take this axis, then it will be wrong. Understand? All right? I hope that's clear. All right. Very good. Thank you, VK channel. Okay, let's get going to the next trick. Next trick is obviously subtraction. So if you have two or more bodies and you see that you can get this body by subtracting another body like a cavity, then use the subtraction trick. Let's say you want to find the moment of inertia about this axis, then I know this body is this body minus that cavity. All right, so use the same axis. Let's say about this point the moment of inertia is I1, and for this sphere about this axis it is I2, then the moment of inertia will be I1 minus I2. That's how you will get it. This is very important. I1 minus I2. This is how you get, only if the axes are the same. Is that clear? I hope, Achyut, you are understanding. Okay, light does not have inertia. That's a separate topic altogether. Let's focus on the session, guys, please. All right, let's get going. Okay, and here it comes, your next question. Let's see how many of you get it before me. And if you feel, only if you feel that you can solve it properly, then only go ahead, else concentrate on whatever I'm teaching. Understand, you're not going to become a hero just because you're going to do it before me, because I'm going to sit and explain it properly over here. That's number one. Number two, you have come here to learn, so it's okay. Be humble, be ground to earth, and if you can quietly sit and listen to me as well and slide me, you can also keep making notes. Find the moment of inertia of a thick shell, inner radius r, outer radius 2r, which is having a mass m. Okay, let's do this. Now, here is the thing. Because it's a thick shell, I know this thing is nothing but a big solid sphere minus a small solid sphere. Keep that in mind. Okay, big solid sphere minus a small solid sphere. Now here is what I'm going to do. A big solid sphere of radius 2r minus a small solid sphere of radius r is going to give me this. But here is the catch. Well, you know what is the catch? The catch is the mass m is not of the big sphere. It's only of the remaining shaded part which you see. So please understand, this mass and this mass are not the same, and they are not even equal to this mass. So we need to use some logic to figure that out. And what is that logic? Well, let me see. Here's what I'm going to do. Let me just find the density of this dude. What is the density of this solid sphere? Alright, so here it is. The density of this is nothing but mass divided by volume. Now what is the volume? Big volume minus small volume, only the shaded part. So it will be 4 by 3 pi 2r whole cube minus 4 by 3 pi small r cube. Now this 3 can go upstairs, so it will become 3 divided by, and m obviously is there, that 4 pi is obviously common. 2r cube is 8r cube. Alright, 2 cube is 8 minus that 1 cube is 7. So it will become nothing but 7r cube. That is what I'll get, and I'll keep it as it is. Is that clear what I just did? I just figured out the density. Alright, now once I figure out the density, think about it. What will be the mass of that big sphere? The mass of that big sphere m1 will be density into that volume, which is 4 by 3 pi 2r whole cube. That's the mass of the big sphere, from which you are going to subtract a small sphere. Alright, so how much will that be? It will be m1 is equal to, okay, density, put that value, it will be 3m divided by 4 pi into 7r cube into 4 pi into 8r cube divided by 3, I believe. I hope I have not missed any terms. 3 goes, 4 pi also goes, r cube also goes, and I am left with only, I believe, just m by 7. Just check that out. Is that m by 7 only which is remaining? Alright, is that m1? Just see if you're getting it, everyone. Alright. Oh, 8m, my bad. 8 is also there. I'm so sorry. 8 is also there. Yes, so sorry. That 8 was there. So it is 8m by 7. Yes, sorry. Yeah, 8m by 7. Yeah. Thank you, Science Priya. And hello, VK channel. Thank you. Good, you're a Vedantu student. Now, if the total thing's mass is m, think about it. What will be the mass of the cavity? Just the mass of the cavity, guys. Think about it. The mass m2, which is mass of cavity will be 8m by 7 minus m, because m is only this part's mass. M is 8m by 7 is the entire thing's mass. So what is remaining? Only the cavity. So that will be nothing but, think about it, it will be m by 7. Is that clear? Why m by 7 came? M by 7 is the mass of this part only. Very important. Very important. Now, once you get this, only then you can solve the problem. Because a lot of people fail to realize without calculating mass and density, you cannot solve the problem. Now, think about it. What will be the moment of inertia of that shell? It will be moment of inertia of that big part minus moment of inertia of that cavity. So moment of inertia of that cavity. So let's start doing this. The big part, it will be, remember the formula was 2 by 5 mass m1 and the radius is 2r whole square. That's the moment of inertia of a solid sphere. I just gave you a table full of formulas. So that's what is needed. Minus cavity. Cavity is also a solid sphere. So minus 2 by 5 m2 but just r square. That's it. Now I'm going to erase this part because I'm going to need some space. But before doing that, let me just substitute the values. So it will be 2 by 5. m1 is nothing but m by 7. And this was not 8. This was just 4r square. And this was 2 by 5. m2 was m by 7. And this was r square. I think now it's fine. Okay. Now I think we can do it. 2 by 35 mr square. And this was 8 4s are 32 minus 1. I think now it's fine, guys. Just check it out. Now it's fine. Now check it out. Yo, okay, very good. Check it out. Yes. Now it will be, I think, 32 minus 1. Yes, 31. And 31 into 2, that is nothing but 62. 62 by 35 and mr square. Just check it out. That's how you get it. Yes. Now it's fine. Just check it out. It was not cube, it was a square. So I think I by mistake put 8 over there. So that's the answer. So my point is, guys, in subtraction problems, the main catch is finding the masses. If you don't find the masses correctly, that's it. I mean, you will get the entire answer wrong. So remember, apart from the radius, the masses is also a problem, and the masses has to be found by density. All right? All right. So let's get going, guys, to the next problem. Let's see how many of you get this. Find the moment of inertia of a sector of a circle about an axis which passes through the center and perpendicular to the plane. I'll tell you where it is. See, this is the axis. Okay, so this is the axis, guys, and it is rotating like this. So aapko bas, you have to just find about this axis what is the moment of inertia of this part. Understand the mass m is of this sector only. Let's see how many of you get it. All right, come on, come on, come on, come on. Come on, think about it. Let's see how many of you get it. I'm going to tell you the answer orally, by the way. Is it very hard? Yes? No? Simple, hard. Acha, chalo, come on, think. I'll tell you one simple trick for solving this problem. The simple trick is, just imagine that there are multiple such, parts over here. Just some parts. Now the angle doesn't even matter. Just forget that that angle is 30. There are some parts over here. All angles are equal. Now each part has mass m and moment of inertia I. What does each part have? Mass m and moment of inertia I. Now when you add all these parts, what does it become? It becomes a disk. And for a disk, guys, what is the moment of inertia when you rotate it about the center? What is the moment of inertia when you rotate it about the center? I just gave you the formula. The moment of inertia is the mass of the disk into r square divided by 2. But here is the catch. Think about it. What is the mass of the disk? There will be n number of parts in that, correct? There will be n parts. 1, 2, 3, 4, 5, 6, 7, 8, n parts. Each part has a mass, how much? M. So it will be n m, correct? That's the mass of the disk into r square by 2. I hope this is clear. Now think about it. Now think about it. When I take that n over there, it will become I divided by n is equal to mr square by 2. Now what is I divided by n? Oh, 1 second, this is the moment of inertia of a disk. So I'll just put the subscript id. That d stands for the disk's moment of inertia. Now if you take the disk's moments of inertia and divide it by n, whose moment of inertia will you get? You will get the moment of inertia of one slice. And how much is it? It is just I. So I will be just mr square by 2. That's it. So understand the formula for a sector and for a disk is exactly the same. I hope. Prija, now this is a direct formula. That's it. By the way, this question in different form came. The angle mentioned I think was 60 degrees or no, and not 30 degrees in JEE Advanced. Understand that. So it is not something else. It is just mr square by 2 only. So if you have an arc, what is the formula? It is just mr square. If you have a part of a sector or just a sector, what is it? It is mr square by 2. Remember that. Yes, independent of the angle. Yes, independent of the angle. That's very important. Yes. I hope this is clear. Everyone. No, it's not divided by 24. A lot of people think it is divided by 24 because they think you have to divide it into, some 6 parts, 12 parts, etc. No, it is not. So Sneha, what has happened? I'll tell you. This was moment of inertia of a disk. Moment of inertia of a disk is how much? Mass of disk r square by 2, correct? But what is the mass of the disk? N times mass of each slice. Now take that n over here. It will become moment of inertia divided by n. So when you take the disk's moments of inertia and divide it into n, what will you get? Moment of inertia of one single part, slice. That's it. That's the formula. I hope now it's clear. Okay. Now some theorems. Let's see. So first is parallel axis theorem, guys. First is parallel axis theorem. Now remember when you can use parallel axis theorem, because a lot of people do not know this. This is valid for 2D or 3-dimensional bodies both. Anything, 2D, 1D, 3D, everything, all kinds of bodies, it is valid. Second thing, the two axes, like the name suggests, must be parallel to each other. That's the second criteria. Third criteria, one of the axes must pass through the center of mass. Understand? So it must pass through the center of mass, only then it is valid. So now what is that formula? The moment of inertia about any parallel axis, this is the axis which is parallel to the axis passing through the center of mass, is given by ICM plus m, whatever the distance is. It could be d, h, l, doesn't matter. Here it is h, so it is h square. So this is that formula. Now this formula should be remembered, and one more thing that you will learn from this formula is that if I take different axes somewhere else, all parallel axes, alright, so imagine you have a body, alright, this is the center of mass, and you take multiple parallel axes like this, 1, 2, 3. You will get different moment of inertias everywhere. You know what? Out of all the parallel axes that are available to you, the moment of inertia will be least when the axis is passing through the center of mass, because the second term will become 0 when you are at the center of mass. So the moment of inertia about all the parallel axes available to you is least about the center of mass. Is that clear now? Is that clear, everyone? Understood? This is very important. Okay, VK, Manoj, Fida, Simran, Manoj, Sanspriya, all right. Let's go to the next theorem coming up. And here it is, perpendicular axis theorem. Now when can you use this and when you cannot? Again, important criteria. Only for two-dimensional objects, not three-dimensional. Only 2D objects you can use it. That means laminar, sheet, all these kind of objects you can use it. Next criteria, you must have 3 perpendicular axes. 3 axes which are perpendicular to each other and concurrent. Concurrent means they must meet at the same point. It should not be like 2 axes are here and the third axis is there. So the third axis is parallel like this. No, it won't work. It has to be concurrent. Next important criteria, out of those 3 axes, 2 axes must be in the plane of the body. Only then you can use it. And then here is your theorem. Let's say y and x are in the plane of the body. Alright, x and y are in the plane of the body. The one which is not in the plane, which is iz, is given by ix plus iy. So this is that important theorem. This is what you should remember. Only valid for ring, disc, rods, etc. or sheets, not otherwise, or triangular sheets, yes, but not otherwise. So remember it. Alright. Is that clear? Everyone, shall we go ahead? All right, Fida. All right. So let's get going. And here we come to the next question. And here it is. Find the moment of inertia of a rod which is rotated parallel to the axis of the rod. Okay. First question is at the end of the rod, second is at a distance of L/2. Let's do both these questions, okay? Let's do both these questions so that you get a hang of it. I know a lot of 12th and dropper students are also here, but also understand there are some 11th standard students who probably need a lot of help out here. Now, when I talk about the end, first understand that I do not know the formula by heart, okay? So I know the formula for moment of inertia of a rod about its center. That is when you rotate like this. So this is the center of mass. About this I know. So if I want to find the moment of inertia about this axis, which is I1, that will be found out using parallel axis theorem. So that will be IC plus M, mass of the rod, into the shift. Now think about it. How much is that shift? That shift is obviously L/2. So just put L/2 over here and square it. So it will become IC. Oh, that formula I should remember, and that is ml square by 12 plus m, and this is nothing but L square by 4. Now take LCM. So this will become 3 over here. All right. So think about it. What are you going to get? ml square by, come on, ml square by 3. That is what you're going to get. So this is the formula about the end of the rod. Is that clear? Very good. I think some of you have already got it. Yes, at the end it is ml square by 3. Come on. Now let's see how many of you get the next part before I complete the solution and I complete my explanation. Come on. At a distance d, which is ये L/4 होना चाहिए था. Sorry, this was not L/2. This was L/4. So I just correct it. So at a distance d, which is L/4, what will be the moment of inertia? Here is the answer. The moment of inertia about this axis I2 will be equal to moment of inertia about the center of mass plus m into this distance square. Okay, so just substitute it and you will get the answer. So it is ml square by 12 normal plus m, and this will be L square by 4 square, which is 16. So what will it become? ml square. and take the LCM if you want to and see what you get, guys. Come on, come on, come on. Come on. 48 is the LCM, right? तो ऊपर क्या आएगा? Come on, what will come on the top? 4, and here you have 3. So 4 plus 3. So what will it become? 7. So it will become 7 ml square by 48. Let's see how many of you got it. All right, very good. Devendra, Jumna, yes. VK channel, Fida, Princey, very good. Ryan, thank you. Aishwarya also got it. Yes, Agrim will study torque in the next session. Yes, in the next session. All right, very good. Let's see how many of you get the next question. Find the moment of inertia of a disc about its diameter. Come on, let's see how many of you get this. Come on, let's see how many of you get this. Very good, Ankit. Moment of inertia about the diameter. Let's do this. Come on, guys. I'm waiting for you. How will you find the moment of inertia of a disc about its diameter? Come on, come on. Let's say I call this I1. Let's see. Okay, some of you have already answered. mr square by 2. Somebody saying mr square by 4. Ankit, hold on. Menti will come. Be patient. Niyaz, don't spam. Okay, I understand you're from Bangalore and even I'm from Bangalore. But hold on. Answer the question. mr square by 4 or mr square by 2? Yes, Saurabh, you have to use perpendicular axis theorem. Very good. So guys, choose two perpendicular axes. Two perpendicular axes, I2 and I1. Now best part, I'll tell you, I1 and I2 are same by symmetry because both are going to divide the circle into two halves and both are in the plane. And the last part is taking the moment of inertia about a perpendicular axis. Let's say I call it I3. Now think about it. I3 will be I1 plus I2, but I3 we already know it is just mr square by 2. That's standard formula. And I1 and I2 are equal, so it will become 2I1. Therefore, I1 will become mr square by 4. Correct. I hope this is clear. Asmi, probably will not get the goodies if you plan something, if you are irregular. Alright, I hope this is clear. Let's go to the next question coming up on your screen. Let's see how many of you get this. The moment of inertia of a disc about the tangent. Come on, let's see how many of you get this. About the tangent, that means it is rotating like this. Understand that. Let's say I call it I1. Come on guys, come on. Alright, Adyut has given the answer. Kya baat hai? Alright, VK, come on, come on, come on. Ankit, don't be so overconfident. Overconfidence will kill you. Okay, so never be overconfident. It's okay to be wrong. If you think that you are always right, then something is wrong. Understand? It's all right. You are a human being. You can make mistakes. You are allowed to make mistakes. Understand that. If you are not going to make mistakes, then probably you are not human, you are a robot. So understand it's fine to make mistakes, but you should learn from that mistake. That's all. Alright, so let's get going. Okay, let's see. And many of you got the answer. By the way, what you need to do is choose this axis, I2, and use parallel axis theorem. Understood? Choose this axis and use parallel axis theorem. How do I find I2? I just figured it out. Remember that perpendicular axis theorem? So I2 was just found out to be mr square by 4 from the previous question. Now the moment of inertia I1 will be I2 because it passes through the center of mass, correct? So shift it plus how much shift? mr square. Okay, so it will be mr square by 4 plus mr square. So how much will it come out to be? Yes, now you got it. It was not 3 by 2. It was 5 by 4 mr square. Correct. That is the answer. It was not 3 by 2. I think Adit, you made a mistake. All right. Let's get going then to the next question. I hope you guys are understanding how to use parallel and perpendicular axis theorem. Hello Yug, join in, come on, start solving. You're a little bit late. Okay, next question. Let's see how many of you get this. Find the moment of inertia of a semicircle about its diameter. That means like this. This is my axis. I'm rotating it like that. Let's see how many of you get it. Come on, let's say I call it I1. I1 is the moment of inertia. Very good, very good, very good. No problem, Ankit, it's okay. Even if you make mistake, I won't say anything to you. Just that learn from it. Alright, come on. Chalo. Koi baat nahi Asmi, no problem. No problem. Attend your regular sessions. That's very important. And yes, you can always watch the recordings Asmi in case you miss for some reason. Okay, Aditya, Shakti, some people have given the answers. Game Flame also has given some answer. Okay, Adyut says 5/4. Let's see how many of you get the correct answer. Now, you know what is the trick? The trick is first complete that disk. Yes, just complete that disk, guys. Now, the moment it becomes a complete big disk, what will be the mass? It will be 2m, right? Because semicircle's mass was m. So the disk's mass will be 2m. Now, try to remember for a disk, right? When you choose two perpendicular axes, what is the moment of inertia? Let's try to think about it. Now here is my logic. If you make it complete disk, okay, then because half and half will add up, so the moment of inertia of that disk will become 2I1. Is that clear? That will become 2I1. I hope this makes sense about this axis. So that disk has 2I1 moment of inertia about this one. Understand I1 is the moment of inertia of the semicircle, not of the disk. Keep that in mind, else you'll get it wrong. Okay. Similarly, about this axis also it is 2I1, correct? And think about an axis which is like this. What will it be? Let's say I call it I3. Let's say I call it I3. What will I3 be? Use perpendicular axis, you will understand it is 2I1 plus 2I1. Isn't it correct? 2I1 plus 2I1 is I3, which is perpendicular to that plane. Yes, very good. So what will it become? It will become 4I1. Now what is I3? Moment of inertia of a disk, guys. What is the moment of inertia formula? mr square by 2. But m is total mass. Be careful. The mass is 2m. So it will become 2m r square by 2. Now here is the interesting part. 2 goes, and therefore I1 will just become mr square by 4. That's the answer. Yes. Same as disk along the diameter. Coincidence, Shakti. I mean, do not heart it that way. It's just a coincidence. 17S heard me go back to the previous slides after the session. Right. So I have explained when to use parallel and when to use perpendicular. So understand, perpendicular to be used when there are 3 axes and 2 of them are known, third has to be found. Parallel will be used when one is through center of mass and second is parallel to the center of mass axis. All right. Okay. Ayush, why don't you put a comment after the video, right? I will definitely reply to you. I'll answer your doubts. Ali, I'm very good. Thank you. Okay, very good. Let's get going then. Very interesting problem. Let's see how many of you can do this. Moment of inertia. Moment of inertia. Ayush, I just said please put it up in the comment box. Of a cuboid about a central axis which is perpendicular to the face. All right. Karthik will start thermal physics very soon. Don't worry, we'll start. We are going to cover everything, and I'm going to tell you a special news at the end of the session. Hold on. Now, that's what we are doing, Ali. MOI problems we are doing so that you get some practice, so that you will be able to solve the problems very quickly. Is that okay? Now, okay, Asmi, I can't give that, yaar. Sorry, I'm feeling cold. Acha. Now, here is the logic. Observe this, you will be surprised. What is the moment of inertia of a rod about a central axis where the length is L? It is ml square by 12, correct? That's the moment of inertia of a rod. I just told you some time back, if you stretch a 2D into 3D, the moment of inertia formula does not change. So make that rod into a sheet. Yes, make that rod into a sheet of width B and length L. The formula for moment of inertia about that same central line will still be ml square by 12. Is that understood what I did? Rod has been pulled into a sheet. That's a property. Very good. Now, think about it. If I choose this axis, correct? Then what will be the moment of inertia? Because for this, it was ml square by 12. For this axis, by the same logic, it should be ml square by 12. Is that understood? Ml square by 12 about this axis. Now, do you see two perpendicular axes? One axis here, one axis there. So what will be the moment of inertia about a central axis which goes inside out like that? Think about it. About this axis, using perpendicular axis theorem. What will I get? It will be this was B guys. ये B square होना चाहिए. MB square, sorry. Okay. Because this breadth is B. So it will be ml square by 12 plus mb square by 12. Do you see that? Perpendicular axis theorem. This was length L, this was breadth B. So mb square by 12 and ml square by 12. Now, just view this in 3D. Okay, just view this in 3D. Just try to understand what I'm trying to do over here. This is length L, this was breadth B, and the axis that I chose was this axis. So the moment of inertia about this axis was m by 12 L square plus B square. That's what I just found out. Now think about it, this was a sheet. What if I extend it? What will it become? It will become a cuboid, where this is length L, this is breadth B, this is height h. Whatever the height doesn't matter, the formula will still be the same, and that's the answer. BK channel, why will 2 come? They are two separate things. This is L square, this is B. They are two different things. Pramesh, you missed a lot. Thank you, Adyot. Adyot, were you there with me? Are you the same Adyot whom I know? Oh my God, kya baat hai Adyot. Welcome, welcome. All right. Is that clear, everyone? Understood? Yes, especially with that double A, very few people, I guess. All right. Great, guys. Great going. So let's get going to the next question. I don't know if there are more questions left, but still. Yes, radius of gyration is left. So guys, what is radius of gyration? If you take a random body and convert it into a ring, that ring which provides the same moment of inertia as that original body, the radius is called as the radius of gyration. I'll tell you. Imagine this is some random body. You melt it and convert it into a ring. That ring has some radius k. So it's a ring. If this mass was m, this is also m. If this body has moment of inertia I, the ring should also have the same moment of inertia I. Then this k is called as the radius of gyration. It's very simple. So I will be, what is the moment of inertia of a ring, guys? mk square. That's it. That's the formula for radius of gyration. If you know the moment of inertia of a body and you know the mass, you can find the radius of gyration, and vice versa. If you know the radius of gyration and you know the mass, you can also find the moment of inertia. Example, say you have been given that, let's say for example, there is a solid. Okay, so there is a solid sphere. You have a solid sphere. So we want to find what is the radius of gyration. First thing you should do is convert it into a ring whose radius is k. Think about it. The solid sphere has a moment of inertia 2 by 5 mr square. The ring has a moment of inertia mk square. Mm goes and you will get k square is equal to 2 by 5 r square. So therefore k will be equal to r root of 2 by 5. and that's the answer. That's the radius of gyration of a solid sphere. So if you take the solid sphere, melt it into a ring of radius r root 2 by 5, the moment of inertia will be the same. Is that clear? Very good. Let's see how many of you can solve the next question then. Very good, very good, very good. So keep hitting the like button, not just over here, but also at the bottom of the screen over here. Hit the like button if you are loving this session, guys. Do not forget to subscribe as well. So radius of gyration of a wheel having mass 10 kg is 2 meter. What is the moment of inertia? Let's see how many of you get this. Come on, come on. All right, all right, all right. All right, Laltan Zova. What a name, yeah. All right, VSG has already answered. Okay, come on, guys. What's the answer? Very good, Asmi. All Vedantu physics teachers are good. All Vedantu teachers are good. All right, Saurabh has also answered. Let's see. The moment of inertia is mk square, where k is the radius of gyration. Remember that. So this is the formula which I just told you. What is the mass? 10. What is the radius? 2. So 2 square. So how much will it be? 40 units kg meter square. That's the answer. Very simple, isn't it? So simple. Now, I will give you the important news. Hold on. For all the 12th and the dropper students. So by the way, first news is that the crash course for all the dropper students has already started, and it's in cyclic nature, as in you can join in at any point of time. That means you will never miss any syllabus no matter when you join. So even if you join today, the syllabus will continue, and whatever you missed will be taught at the end, because it's been divided into modules. That's how it's been done, with lots of test series, part test series, full test series, and also the discussions around them. Also get lots of assignments, doubt solving, and it's a two-way interactive platform with class teachers in the Telegram group as well as during the session. Also lot of quiz sessions, lot of motivating sessions, lot of tips and tricks sessions which will happen during the crash course, so you cannot afford to miss. So if you want to join it, if you're a dropper or a 12th student, understand this is for you, 12th and dropper students. The link is in the bio, by the way. So you will get a 20% off on 10,000 rupees, which is the course fee, and you will get it only for 8,000 rupees. So which coupon code will you use? SHCC. That's the coupon code you will use to get the 20% off on 10,000 rupees. Is that clear, guys? I hope it's fine. All right. And I hope you have liked today's session already. Have you liked today's session already? And have you subscribed if you are new? Yes. So now what is the important announcement? Yes, so let me tell you the important news. Yes, so let me tell you that. Come on, come on, come on, show some love. Already. So here is the thing. Okay, so I'll be conducting Menti quizzes and all that for sure. For 12th standard students, I'm conducting a Menti quiz on Friday, not Thursday, because on Thursday, I'm going to conduct a lecture on dipoles and dielectrics. So after that, I'll be conducting a Menti quiz on Friday morning around 9 AM or something like that. So that's announcement number 1. So Menti quiz for all the 12th standard and the dropper students on electrostatics, gravitation on Friday. Remember that. Morning, most probably 9 AM. And like we all know, the Monday, Tuesday, Wednesday slots are for the 11th standard division. Thursday, Friday, Saturday slots generally for the 12th standard division. Now, today only I got to know some interesting news. Remember, just few days back I was talking about when will the JEE Mains exam happen? When will the JEE Mains exam happen? So, yes, do you remember that? All right. So here is the thing. So most likely 99% ये होने वाला है that your JEE Mains exam might be shifted to February. Most likely it will be shifted to February, yes, and that too maybe in the last week of February. That's what the rumors say, and the decision will come very soon. Understand, you should take this news with a pinch of salt, but still I'm telling this to you. I'll tell you what is good about it if that happens, because we are not doing one entire chapter in one lecture. Because if we do that, we'll be doing things very fast. But what's the point? Will we cover all the concepts? Obviously no. What we are doing instead, we are giving enough time, keeping in mind that the exams are in February or January, and we are going to complete the entire syllabus. That's what at least I am trying to do over here. So understand the process of flash series. The intention is to complete everything as much as possible before your exams, before your board start, and you should understand in depth. It's not that I want to do everything in one go. If you want me to do rotation in one lecture, I could have done that, but what's the point then? Understand. So that's one good news, and most likely if that happens, then even the board exams will get shifted by one month, and that will give you a breathing space. Let's see if that happens. We do not know. You should take this with a pinch of salt. Is that clear? All right. So yes, VSG, don't worry, Enthuse is here. This was Shreyas here. I hope you have enjoyed the session today. Bye bye. Take care. Have a great time ahead.